Okay, yeah, I'll share my screen again. So yeah, I don't know how many of you have been to the maths refresher workshops or the stats ones, but we have 2 more stats workshops next Tuesday and the Tuesday after that, and 2 more microecon workshops, which is also like every Friday. So this Friday, the Friday after that, and the Friday after that. So today I'm basically just gonna go over budget constraints and preferences. So just kind of like an intro. And I'm not going to necessarily do like practice questions, but I do have some like examples and stuff in the slides. And I'll post the slides on the Facebook event, and we'll post a recording on our YouTube channel, which should be up probably by next week or the week after that. We just want to post a lot of our videos together. And if you have any questions, just like unmute yourself and like ask the question. If I can't respond to you, like if I don't have an answer for you right now, I'll definitely like get back to you. So yeah, I'm just gonna start. Does anyone have any questions before we start? Can you hear me okay? Is it all good? Okay. So I'm gonna start. So basically, I'm gonna go through preferences. Basically, it's the 4 like main assumptions that there are for preferences. We're gonna go through indifference curves, what kind of like a normal indifference curve looks like, and the other 3 types that they usually ask you like in midterms and finals and stuff. So perfect substitutes, perfect complements, and the quasi-linear function curve. And then there's just like 1 slide on the marginal rate of substitution, which is important because sometimes they ask you about that, but it's like pretty simple. And then I'll go through budget constraints and just explain what the budget line is, how that works, and what happens if there's a change in income price or a change in income and price. So today's workshop is pretty straightforward. And it should be okay. And this is my first time teaching a workshop, so if I'm kind of like blabbering, just please excuse it, and you can tell me when to like move on. So yeah, basically preferences, it's just kind of like a little summary. And one of the main assumptions is that consumers can rank bundles according to their preferences, and a consumer's set of like their affordable bundle always depends on prices and their income as well. So like basically when there's a change in price and when there's a change in income, their preferred and affordable bundle can change. So that's just like a pretty straightforward like thing. Does anyone have a question? If you don't have a question, can you just keep yourself on mute, because sometimes there's like background like noise and stuff. But if you have a question, just like unmute yourself. Yeah, so these are some more kind of like assumptions, but not like the main 4 ones that they actually like question you on. So there's some stuff in the slides that I won't necessarily like go through in a lot of detail, but you can like, I'll post them and you can like go through them. So one of them, like basically one of the main symbols that you have to know is this one right here. I don't know if you can see like my cursor, but this is to denote the preference relation. So yeah, we'll go through that in a little more detail. And a lot of times we denote like consumption bundles by the letter S. I'm not really sure why, but that's what we did last year. Yeah. So also different individuals have different preferences, but there's some properties of preference ranking that kind of like apply to most individuals. So it's kind of like a little more like general. Yeah, so S is a set of bundles of 2 goods, and they're both perfectly divisible. So that's the thing in econ, sometimes you just kind of like have to make a lot of assumptions about like what is happening. Yeah, somebody had a question. Yeah, so the PowerPoint slides will be available later on as well. Yeah, so yeah, you just kind of have to assume, like last year we had like our prof's like favorite example would be like beer and burgers, or like beer and some other type of food. Like that's what he would go with all the time. So you just have to assume and like take them to be kind of like the same value in a sense. Yeah, so for example, in this case, we're just gonna go by two things that are pretty similar. So good X is cheese and good Y is tofu. So this is just some like notation of how you kind of show what the bundles are. So good X, which is cheese, is you have to kind of like if you see it online, it's usually like in a bold lettering, like a bold font. And yeah, these are some more symbols. I'm going to explain them in the next slide. So yeah, there can be three types of relationships, like generally, that we talk about, and I'm going to like explain them now. So firstly, it's the like weakly preferred, which is denoted by, it's kind of like pretty similar to math when you do like the greater than and less than sign, but it just looks like a little more like in cursive, if that makes sense. So for example, if you weakly prefer X to Y, it means that you prefer X to Y, but you are also a little bit indifferent. So we put the indifference like notation, which is like the squiggly line underneath it. If you are just indifferent, like you don't care if for like X or Y, like they're interchangeable, for example, like cheese and tofu, which can be for some people, you can just use the indifference like squiggly line. But if you strictly prefer like X to Y, like you will not take Y, it doesn't work for you. For example, if you're like vegetarian and X is like tofu and Y is like, I don't know, like chicken is like a bad example, but basically like Y is not good for you, you don't prefer it at all, and you will just like not use it. So we denote it like that. And if something is strictly preferred, so if X is strictly preferred to Y, it also has to be like kind of weakly preferred, if that makes sense. Like it kind of like goes up in levels, but it can't be the other way, that Y is weakly preferred to X. Like that's why those are like the symbols. Yeah. So it's not that complicated. I feel like I might make it sound like weirder than it is, but it's pretty simple. So these are the four assumptions that you have to know for preferences. So the first one is completeness. So given any two bundles, X and Y, the consumer can rank them, which is basically like the whole like kind of like essence of preferences. And transitivity, which is basically kind of like a ranking type of thing. So if, for example, there's three goods, X, Y, and Z. So if you prefer X to Y and you prefer Y to Z, it's assumed that you prefer X to Z as well, which isn't always necessarily the case. Like it doesn't like always translate correctly like in real life, but for the most part, like this is what you assume. The third one is monotonicity. So if bundle X has more of both goods than bundle Y, then the consumer strictly prefers X to Y. So this is basically like a quantity thing. Like if there's more goods, you prefer more of that. I think there's another. Yeah, so just give me a second. Sorry. Just a second. I'm just gonna turn on my do not disturb right now. Okay. Okay, perfect. So yeah, so monotonicity, that's pretty like straightforward as well. And then continuity. So preferences are like continuous. This one is a little hard to explain, so I kind of put like a little like thing from that I found from a PowerPoint. So also like to confirm that a lot of the like things that I'm using are from slides that I used last year, like to study from, and also like online resources. So if you like wanted like the originals, I could give those to you guys as well. Just like let me know. Yeah, and preferences are said to be rational if they satisfy both completeness and transitivity. So I think it was in the midterm when they would like ask you if like a good is rational or not. So you have to basically show that it is if it passes through completeness and transitivity. And yeah, these are just the 4 ones that you have to know. There's nothing like extra that you need to know. But yeah. So now I'm just gonna go through indifference curves. So we denote, I don't know why I keep saying donate, we denote it with like an italicized I with an X at the bottom. So this is a set of bundles that are as desirable as X. Yeah, so basically the indifference curve has to be a curve that passes through the values of X, and indifference set and indifference curve are basically terms that are like interchangeable. They're not really like any different things. Yeah, and an individual's indifference map is the set of all indifference curves that represents their preference ranking. So there are 3 properties of indifference maps that you should know and remember. So indifference curves cannot cross each other. We'll see that later on as well. Like even when you're doing like perfect substitutes or like perfect complements and stuff, like they never cross each other because they can't be on the same like line, and they always like slope downwards, and they're not thick. Like it's just like a line. Yeah. So basically, this is sorry. Yeah, this is what like a normal or like a general indifference curve looks like. So like you can see on the right side, Ix is equal to y dot y indifferent to x. So yeah, basically the consumer here is indifferent between goods X and Y. So bundled Z, which you can see over here, is strictly preferred to X, and you can see that because it's above the curve. However, bundle W, which is at the bottom, is strictly inferior to Y because it's also like below the curve. So it's basically that, like it's, if they just ask you to draw an indifference curve, it's pretty straightforward and simple. And then I'll go through the other types of curves that we have. So the first one that is quite popular in exams actually, especially in the midterm, there's definitely going to be like a question on this, is the perfect substitutes one. So for example, in this like diagram, good 1 is South Africa's oranges and good 2 are Californian oranges, which is basically like it doesn't matter. It's kind of like, yeah, it's basically like an indifference thingy, that it doesn't matter if you get South African oranges or Californian oranges. So it's always just straight lines for perfect substitutes, like they're always parallel. And this depends on like the quantity that you have, which sometimes they specify, and they probably will for the midterm, just so that it's easier for you to like draw. And this would be like an example of a utility function. I don't know if you guys have covered utility yet, but I'm gonna talk more about that next week. Today is just kind of like preferences and budget constraints. But yeah, so a utility function would be like utility open bracket x1 comma x2 is equal to x1 plus x2 because you derive like equal utility from both the goods. It's not that one is more and one is less. Moving on. The drive, yeah, so this is a question in the chat, if the drive is still available. I don't think it is because I actually tried to go on it like last week to look for some stuff for my classes. But yeah, I don't think it's available anymore. But if there's any resources that you want that you know were on the drive before, I can probably find them for you because I have a lot of like stuff saved from last year for 250 and 257. Yeah, so the next one that we are going to look at, the next curves, are the perfect complements curves. So perfect complements are basically goods that that are perfectly in sync. So this is a good example because good one is left shoe and good two is right shoe. So you don't, you kind of need them to go together. I remember in school, they always used to give us like a bread and jam example, but I feel like this makes a lot more sense to have shoes. So basically one set, like one quantity of good one and one quantity of good two make one pair. That's how you should think about perfect complements. So I think there's another question. Yeah, the drive was really, really helpful. But I'll let you know if it's working or not. Just send me a message on Facebook. I'll put my contact stuff at the end of the presentation, and just message me so I don't forget. So yeah, point A represents one pair of shoes. So as you can see, it's one quantity of good one and one quantity of good two. So that's the corner of the curve. So these don't technically count as curves because they're like straight lines almost, but that's how it always is for perfect complements. Point B represents two pairs of shoes. So basically, like you can see, it's like pretty self-explanatory. And also the consumer is indifferent between point A and point D, because point A, he or she has one full pair of shoes, like a left and a right. And then at point D, they have three right shoes, but one left shoe. It doesn't actually, like, it doesn't benefit them in any way. It doesn't change, like, you know, like they're not gonna just wear random like right shoes and just stick with the left shoe. Like it's pretty silly when you think about it. So yeah, like a good utility function example for this is u is equal to minimum brackets x1 comma x2 close bracket, because you just need like a minimum of one of each x1 and x2, which in this case is a left shoe and a right shoe. So yep. Does somebody have a question? No? Okay, so this one is the one that is kind of a little more complicated than the other two. The other two are pretty straightforward, quasi-linear utility functions. So this is when you kind of have, like, for example, u is equal to f of x1 plus x2. So f of x1 could be like a log, it could be like a quadratic, anything like that. So it's a function plus just like another quantity. So yeah, on the like axes are always the same. Like it's good one on the x-axis and good two, the second good on the y-axis, and they specify usually in exams which way they want you to do it, because that makes a difference in the way that you draw your curves. So yeah, so these are like some assumptions that you need to know, that we assume that the first derivative of x1 to be more than 0 and the second derivative to be less than 0. So this is just something I put in there so that you can like remember it. So basically, I'm gonna like walk you through what this curve is like. Okay, I'll just like answer a question about the drive. So basically, last year, the person who was the honors rep gave us access to this Google Drive, and it had a lot of past past midterms, past finals. It had like a lot of problem set stuff, and also just like general like PowerPoints and like things just to like get a little ahead. But it was for all the core econ classes, like honors classes. So 250, 257, it would be 352, which is what I'm taking right now, which is macro and like stuff like that. But I feel like it doesn't exist anymore, and I'm not sure why. It did all of last year, but I'll let you guys know, or I'll ask Matthew, who is the honors rep, to actually talk to you guys about that. He would have definitely come into one of your classes. So yeah, I'll let you know. Even if the drive isn't available, I do have some resources, and Matthew definitely has resources for 250 and 257. So just like ask us later and we'll help you out with that. but I'll check if the drive is working. I don't think it is, but just in case it is, we'll let you guys know. Yeah, so here, basically, this is a pretty straightforward quasi-linear utility function, which is u, like utility, open bracket, x1, sorry, comma, 0, close bracket. And so if it's a 0, it doesn't really like the, like the second value like doesn't really exist, like it doesn't matter. So all you have to do in this is like a function of x1, which should equal 10. So they'll give you like a concrete value, and then you have to kind of like make a graph essentially out of it. And yeah, this one, like I don't think I'm explaining it very well, so I will move past it and write some notes about it. When I put up the PowerPoint, I'll explain it better, but right now I think I don't really know how to. So yeah, I'm gonna move on. So this is the marginal rate of substitution. This is something that they may ask you in exams, like how to calculate, but it's not that hard. So the marginal rate of substitution is basically that people are willing to give up a bit of something in return of a bit of something else. So for example, for me, it would be that like my two preferences, for example, like in between fruit, I like oranges a lot more than I like apples. So I would be willing to give up some quantities of apples if that means getting more quantities of like more oranges. So it's kind of something like that. Yeah. So this is from a past PowerPoint, which was pretty helpful. So I just put up like the slide. Yeah, so the slope of the curve at X bar is a measure of how many additional units of good 2 a person is willing to give up in exchange for having an additional unit of good 1, while keeping her utility constant at level U. So basically, even for me, like for example, even if I get less apples, but if I get more oranges in exchange, my utility isn't going to decrease because I prefer oranges to apples. So it's basically like that. So the marginal rate of substitution of good 1 for good 2 at the point x1 bar and x2 bar is basically a ratio. So this is when you start basically doing like calculus. So I've put the formula in there. It's not that complicated. The only thing that you have to remember is to put a negative sign in front of the answer. So the formula is like negative, the derivative of x1, and then over the derivative of x2. Well, like the function of x1 and x2 in respect to x1 over the derivative of the function in respect to x2, which just gives you like this. So it's not that complicated. In exams, they don't try to overcomplicate it either. As long as you remember the formula and do like a couple of practice things, you should be fine. So moving on, I'm just going to talk about budget constraints that are also pretty like straightforward. So this is what a budget constraint like kind of formula looks like. So they'll give you two prices, P1 and P2, which are respective prices for the good X1 and good X2. And they give you a budget Y, which is basically like a monetary value, like it could be $10, $100, like $50, whatever. And this is just like a rearranged, like x2 is equal, like it's just like a rearranged formula in case you like ever need to just calculate one good, which they may ask you. So the slope of the line is the derivative of x2 over x1. It's pretty I'm pretty sure you guys are familiar with that. It's not that complicated. You would have definitely done it in high school. So yep. And yeah, so for example, if P1 over P2 is equal to half, this indicates that we would be willing to sell 1 unit of, that when you sell 1 unit of good 1, the consumer can buy half a unit of good 2. So it's basically just like a ratio. Yeah, the slides will be available for Zahra, who just asked in the chat. And yeah, so it's basically just a ratio just to kind of like quantify how much you prefer one good to another. And this is also the marginal rate of transformation is minus P1 over P2, which they may ask you as well. They have a lot of questions about marginal rate of like substitution of transformation, but most like the formulas are pretty straightforward, so they don't try to complicate it. Yep, so that's basically like an intro to what the budget constraint looks like. Now this is the budget line. Like I'm gonna kind of just go over how to construct a budget line and what different parts of it mean. So for example, Jose likes to collect t-shirts and movies. So this is what he likes to buy. Like he likes to go out and buy t-shirts, buy movies, and the number of t-shirts that he's going to buy, which I'm considering t-shirts to be good 1, is on the x-axis. Movies are, which is good 2, is on the y-axis. So his budget constraint, which is y, which is like here, which is y on the screen in the formula, is equal to 56. So you can think of y as like his income, and we do denote income as y. So you can just think of that like, so he earns $56 in a given period of time, and that's the amount of money he can spend. He can't go over that. Like that's all the money he has. So t-shirts generally cost $14 and movies cost $7. So if he spends all of his money on t-shirts, he can only buy 4 t-shirts, because if you do the math, like 56 divided by 14 is, okay. Yeah, if you do the math, 56 divided by 14 is just 4. So how to construct a budget line is basically by finding the intercepts, like the y-intercept and the x-intercept. So we found that 4, 0, I'm just gonna mute whoever's not on mute just so that we can have no disturbance. Okay, I think they muted themselves, which is fine. So yeah, so the x-intercept is 4, 0, because if you spend all your money on t-shirts, you can only buy 4 t-shirts. And on the other hand, the y-intercept is 0, 8, because if you spend all your money on movies, you can get 8 movies, which is 56 divided by 7. So this is the easiest like form of constructing a budget line, which I don't know if you guys have done a problem set already, but I'm pretty sure they would have asked you this in your first problem set. Yeah, so what is a budget constraint? This is the same graph from the last slide. The red triangle is basically what Jose in this case can afford. He can't go over the budget line because these goods, the green kind of area, is not feasible to him. He can't afford it. There's no way that he's going to get it unless like prices change, his income increases and stuff like that. So it's just it's just a triangle. So that's all you have to know. Moving on, these like changes in income and price and stuff like that are pretty easy, but I'm just going to go through them in case somebody's confused and stuff like that. So for example, for a change in income, if Jose's budget or income drops from $56 to $46, the budget line is going to shift inwards because he's not able to afford some of the goods that he was able to before. So yeah, it's kind of like the demand and supply curves that you used to do in high school, like when they shifted. So that's what it is. So to plot the new budget line, you do the exact same thing that you did to plot the first budget line, which was to find the intercepts. So in this case, you would do 42 divided by the price of the t-shirt to find the x-intercept, and 42 divided by the price of the movies to find the y-intercept, which in this case, the y-intercept is 6 and the x-intercept is 3. So you just connect basically the 2 intercepts and that's it. And when there's a drop in income levels, there are fewer opportunities that are available for consumption and like fewer goods that you can essentially buy, which is like straightforward as well, but this is just how to show it in a graph. So the next part is to talk about a change in price. So this is when only one price, like the price of one good changes. So in this case, only the price of movies are changing. So for example, we're just going to go with the same example because it's easy to follow along then. So if movies double in price from $7 to $14, the line is going to shift as well, but it's not going to be a parallel shift because the t-shirt, like x-intercept isn't moving, like nothing is changing with the t-shirts. You can still only buy 4 t-shirts if you spend all your money on that. Yeah, so the y-intercept now would be 56 divided by 14, which is also equal to 4, because now movies and t-shirts cost the same amount of money. The intercepts are the same. So this is what it looks like to have a shift in like the just when there's a change in the price of one good. And again, fewer opportunities for consumption because now there's no way, even if Jose spends all of his money, that he'd be able to afford 8 movies at the same time because that's too expensive for him. So this is the new budget constraint triangle. Yep. So this is pretty like straightforward stuff. Like the beginning of the course is pretty straightforward. The midterm is pretty easy as well. You should just do all the problem sets and you will be fine with the midterm. Yeah, so this is if there's a change in income and price. So if prices of movies increase from $7 to $12 and Jose's budget increases to $63, what you're gonna want to do is just construct the intercepts again. And I like to do this like kind of like structurally so you don't get like confused and overwhelmed because there might be price changes in like in both the goods. One might go up, one might go down, and they might change the budget as well, but it's still pretty like straightforward. I'm just gonna check if there's, okay, nothing in the chat for me. So to do this, again, you just do y-intercept is equal to $63, which is the new budget, like new amount of money that he can spend, divided by 12, which is how much it costs for movies. So this is the y-intercept, and the new intercept is 5.25, so you just plot that on the graph, and the x-intercept is just 63 divided by 14 because the price of the t-shirts didn't change from like the original price, so it's 4.5. So you just plot that on the graph, and then a lot of times in like problem sets or like questions, like your professor, like TA or whatever, will just ask you to plot a change in price and a change in income, and they'll give you the values, and you should try to do it usually on the same graph so that you can like visually see how their budget like constraint has changed, like just to see graphically all together, it makes it a lot more sense. So you could see that this used to be the triangle. I don't know if you can see my cursor actually, but the dotted line was the original budget line, and the big triangle was what Jose could afford before. But now it's different, like because the prices increased, but he can afford more t-shirts. So this is also like they might ask you to like analyze, so what does this mean for the consumer? So in this case, it means that because the price of movies has gone up, Jose can't afford as many movies as he could, but because the overall like budget has gone up from 56 to $63, he can kind of afford like more goods in some sense. So it's kind of like he's losing some with the movies, but he's gaining some with the t-shirts, because now if he spends all of his money on t-shirts, he can buy 4.5, which I know doesn't actually make sense, but it could make sense for other goods. But he is being like, he can afford half of a more t-shirt, if that makes any sense. Yeah, so this is just like another representation, because like in the examples, I just did it with the intercepts, but this is kind of what it looks like if they ask you to label the the curves, you would do y over p2 for the y-intercept and y over p1 for the x-intercept. Just, yeah, labeling is important. So this slide is what you should use to label your graph. And p1 over p2 is a half. So basically, it's the marginal rate of transformation of good 1 into good 2, which is basically it. So this is it for me. I'm gonna stop, I'm gonna show you like the contact thing. So if you have any questions, the best way to talk to ESA or like me or like whoever, if you wanna get involved, like whatever you want, all your questions, is either through Facebook or email. So our email is esamcgill@gmail.com. We respond like pretty fast, but if like sometimes it gets lost in all the other emails. So Facebook is really good. If you message us on Facebook Messenger at the Econ Students Association at McGill, we will respond to you like pretty fast, like because there's like 9 of us on the team and somebody's always online, so we can reply to you. The honors rep is Matthew Fisher. I'm pretty sure that you guys have already heard from him, and he's teaching the statistics workshops. So he's in my year, we take macro together, and he can answer your questions in recording to like the courses better than I can. Like even for micro, if you think I was unclear, which I might have been, you can clarify with him. Like there's no issue, there's no problem with that. But if you want to contact me, you can just search up my name, which is Sana Ratra on Facebook, and I will be posting all these slides on the Facebook event, and we'll put it up, like we'll put up the recording whenever our YouTube channel is live. So I'm gonna stop sharing. Does anyone have any questions in regarding to like the presentation or like just like in general? It wasn't that like a super long presentation because the beginning like concepts aren't that hard for micro, but if anyone has any questions, I can stick around. Otherwise, that was it for me. Thank you guys for coming. I'm sorry if it was a little bit awkward because this is my first time teaching. I promise I'll be better next week. But if you have any questions, I'm gonna stop recording.